fourth and final video on variables on both sides. So if you notice here, we have definitions on the screen. And we have identity and no solution. These definitions describe specific types of equations that you actually have not encountered yet. All the equations that we've done up until this point, from our one-step equations on up till just this past video, have all had a definite answer. We got x equals something or k equals something. So you've gotten one solution that made the equation true. And that's not always the case with every equation. And we're going to look at those. So one example of that is identity. And the definition of identity, you should be jotting this down in your notes, is the equation is true for every possible value. That means any number that you can think of is going to make this equation true. So that's also known as, our AKA there, infinitely many solutions. That means that when you get to an equation and you identify it as identity, this is its description, but my expectation of you is to know that that means there are infinitely many solutions. So this solves your equation. This is your final answer here. This is your description. This would be your answer, infinitely many solutions. Now, an example of infinitely many solutions would be, if you want to write this out to the side, just something simple, x plus 1 equals x plus 1. Notice that both sides are exactly the same, and no matter what number you throw in there, 2 plus 1 is 3, 2 plus 1 is 3. You could put in negative numbers. A negative 1 plus 1 is 0. Negative 1 plus 1 is 0. These are both x's, which means that whatever number you pick, both of those x's will be replaced by that number. So you can't pick two different numbers. You can only pick one at a time, but it doesn't matter what number you pick. That equation will always be true. So that is an example of an identity, and its answer would be infinitely many solutions. Now the other one, no solution, that is its description, and it's also how you can answer the question. This equation is never true. There are no values for x. You will not ever find one that exists. And this symbol here, this is called phi, and this symbol here indicates no solutions, like a 0 with a slash through it. So you can write out the words no solution, or you can use this symbol. Either one will indicate no solution, but a simple example of this would be x plus 1 equals x plus 2. Just take a minute and think of all sorts of numbers that you can plug in for x. Can you ever have a number and add 1 to it, and then take that same number and add 2 and get equivalent answers? And the answer is no. So this is an example of no solution. Notice that the sides are just about the same. Our variables are, coefficients are the same, variables are the same. So our linear terms are exactly the same, but our constants are not. So that makes a big difference in identity and no solution. So be very careful with these two fairly simple equations here, or concepts, but very easily can be mixed up. So let's take a look at a couple examples of these. So first one we're going to look at is t plus 8 equals negative t plus 6 plus 2. And this is going to come in handy what I've mentioned earlier about identifying all of your linear terms. So let's go through here and let's identify our linear terms. I have a 1t here. I have a negative 1t there. So that's very important to pay attention to, negative 1t. And then I have a positive 2t. Alright, so I actually have 3 linear terms in this problem, but notice that here's my equal sign right here. 2 of those terms, I'm going to underline them now, are on the same side. Now, because they're on the same side, we are not going to use inverse operations. Same side, same sign. You can think of it that way. we're just going to do exactly what this tells us to do here, what I have highlighted in green on the right hand side. Negative 1, if you need to put that in there to help you, negative 1t plus 2t. Well, negative 1 plus 2 would leave us with just 1t. Then don't forget about that plus 6 that's there in the middle of our green highlighting there, and we still have our equal sign. We have our 8, a positive 8 there, and our t. I haven't done anything to the left hand side just yet. All I did, and I will actually do this in another color, is I took negative 1t and added 2t. That's where that came from, in case you need to see that. What I did in pink there. Now what I've done, and let's go with maybe blue here. Now I still have this same linear term here and this same linear term over here, now that I've completed my collecting like terms. So my linear terms are the same, but what you should notice is that my constants are not. So let's think about this. If I take, I'm going to put a box around my problem right now. If I take, this is not your answer, so this box is just kind of pull out this information. If I take any number and add 8, so pick a number in your head, add 8. Use that same number because we're still dealing with t, but now add 6. Are you going to get the same thing? Will you ever get the same thing adding 8 and adding 6? And the answer to that is no, you will not. So this is an example of no solution. So again, you can write no solution, or you can use the symbol for no solution. Either way, this is your final answer. So I'm going to box this in red. This is your final answer. No solution. So let's go over here to the side. I want you to try one. Let's see. Let's give you 3 times the quantity 4b minus 2 equals negative 6 plus 12b. So take a moment, pause the video, and see if you can solve that for b and determine what the solutions will be. Alright, let's look at how well you did with this equation. The first thing you should do, what we've done several times now, we have a number attached to our parentheses. This indicates multiplication, which automatically indicates distributive property. So let's distribute 3 into our parenthesis. Hopefully that's become second nature to you now. 3 times 4b gives us 12b. And then we have 3 times negative 2, so positive 3 times negative 2 gives us a negative 6. And then if you look at the right hand side here, there's nothing really going on here with this side, so I'm just going to rewrite it. I can't collect like terms, there's no distributing, so negative 6 plus 12b. Now let's look at this. Let's identify our, let's do this with yellow, let's identify our linear terms. I have a 12b and I have a 12b, and they are on opposite sides of this equal sign. So just like I did in the problem over here, I do have the exact same linear term. Alright, well let's look at our constant terms. I have a negative 6 and a negative 6. So even though, and I have some people that will argue that these two sides are not the same, but even though they're not in the same order, I could use the commutative property, going back to our properties, leaving this 12b minus 6, and I'll rewrite that so you can see that, 12b minus 6, I could use the commutative property and on the right hand side change the order. So positive 12b could be written first, and my -6 would be written next. So using commutative property, I can change the order, and there you have it. You have an equation that is identical on both sides. So you could pick any number you want, plug it in for b, and you will find that it works. Every number you can think of will work. So your answer to this one, hopefully what you got, was infinitely, I'm going to abbreviate, many solutions. Infinitely many solutions. Now please don't abbreviate if you need to make sure that you know what it is you're writing, but just for the lack of space and time, we have infinitely many solutions. So there's an example of no solution and infinitely many solutions on your equations. Okay, now that we've gone through the entire section on solving equations with variables on both sides, here are your summary questions, and you have 2 of them. So make sure with your notes you include your work, all of your work. Answer the question there, part A, solve that equation for y, and make sure you check your solutions. And then part B, you need to identify your variables, you need to set up your equation, you need to solve your equation, and again you need to check to make sure that your solution 1 makes sense and 2 does satisfy the equation